Problem number 2. How many 4-digit numbers n have the property that the 3-digit number obtained by removing the leftmost digit is 1/9 of the original number n? Alright, well, let's get a handle on what this is saying here, right? That's the first thing. So we've got some 4-digit number, and let's say those digits are A, B, C, D, okay? So, so we know that this is n, right? So this is n, and we're just this in this particular representation is not A times B times C times D. I'm just using this to represent the thousands place, hundreds place, tens place, and ones place. Okay. And if we take off the leftmost digit, so let's say we take off this digit, then that resulting number is 1/9 of the original number, A, B, C, D, right? So now that I've taken off this digit, this doesn't hold anymore. But so essentially we're looking at B, C, D is equal to 1/9 of A, B, C, D. All right? And this notation is a little strange because a lot of times you see variables that are listed next to each other and you think of multiplication. So let's write this in a way that is more algebraic, because this is just representing digits. So if I was going to write this algebraically, we can actually write the number in expanded form. So the number A, B, C, D is actually 1,000 times A, the first digit A, plus 100 times B, plus 10 times C, plus D, and the ones digit. Okay? So you see if we had like the number 1, 2, 3, 4, it's equal to 1,000 plus 200 plus 30 plus 4. Alright? So we don't know what the digits are, but we're just going to represent them with A, B, C, and D. So this number, A, B, C, D, the 4-digit number n that we're looking for, we can represent this way. And we know that if we take off the leftmost digit, we would end up with 100b plus 10c plus d, right? And that result would be 1/9 of the original number. Okay? So that's what we're told. 1/9 of the original number is equal to the number with its first digit chopped off. Alright, so now we have an algebraic equation. And we just have one equation and 4 unknowns, but but let's see what we can do with this. First thing I want to do, I want to get rid of fractions. So I'm going to multiply both sides by 9. Okay, and I have to multiply the whole of both sides by 9. Okay, so 9 times 1/9 is just 1. So I'll end up with 1,000a plus 100b plus 10c plus d. Alright? And then I have to distribute the 9 here to all the terms. Okay, because I have to multiply the whole thing by 9. So that'll be 900b plus 90c plus 9d. Alright? And the next logical step is to combine like terms. So let's subtract 100b over here and subtract 10c and subtract d, okay, on both sides. So we'll subtract 100b minus 10c and subtract d from both sides. All three of those things. We'll do it all at once. So what's left over here, we have 1,000a, but the 100b minus 100b is 0, 10c minus 10c is 0, d minus d is 0. So all we're left with over here is 1,000 times a. And that's equal to, what? 900 minus 100b. 900b minus 100b is 800b. 90 minus 10 is equal to 80c. And 9d minus d is 8d. Okay. Well, alright, we're getting there. It's getting simpler, right? And I can also see that everything here is divisible by 8. 1,000 is divisible by 8, right? Because that's 125 A. And 800 is divisible by 8, which is 100 B. And 80C, it would end up being 10C and D. Okay, so essentially what I've done is just divide everything by 8. Okay, and over here too, divide everything by 8. All right, and that's what I end up with. And you can see that this 100B plus 10C plus D is just the number we had up here when we truncated, when we chopped off the leftmost number, right? So essentially, the A digit has to be 125, or say, so essentially, if we take 125 times A, we should end up with the last 3 digits, okay? So let's look at what the possibilities could be, because we know this has to be a 3-digit number, and if we multiply this like by 10, that's too big, right? Because that wouldn't give you a 3-digit number. So we are limited. If you multiply this by 0, of course, you won't get a 3-digit number. If I do multiply it by 1, if A equals 1, then BCD will be what? It will just be 125. So we know that's one number that meets that criteria. All right, so if n is equal to 1125, then we know that 1125, 1/9 of 1125 is equal to 125, and you can check that and see if that really works. But just by this equation, that should work. So that's one possibility. If we have A equals 2, then BCD would have to be what? 250, right? So another possibility for n is when n is 2250. So if you take 1/9 of 2250, you should get 250, hopefully. All right. So, and we could keep going. So let's, we could compute all those out, but let's look for the biggest A possible. Okay, and the biggest A possible is going to be limited by the fact that BCD has to be this 100B times 10C plus D has to be 3 digits. Okay. So let's figure out what the biggest A can be, such that BCD is 3 digits. Okay. So so essentially we've got 125, right? And we know if we divide that into 1,000, we get 8, right? Because we already kind of did that up here. So if we and that's too much, right? 8's too big. If we take 125 times 8, that gives you a 4-digit number, not a 3-digit number. So let's back off a little bit. 1,000 is pretty close to a 3-digit number. It's just a 3-digit number with 1 added to it. So if we take 125 times 7, what do we get? We get, let's see, 35, 14, and wait a minute. Yeah, 35, 14, 17, and 7, 8. 875, right? So, is that right? So I guess that makes sense, because if we add another 125 to it, that should give us 1,000, right? So if A is 7, then BCD would be equal to 875, all right? And our n would be 7875, okay? And equals. All right, so, and we can't go any bigger than 7, because if we take a 7 times 125, we get 1,000, which is a 4-digit number. So essentially, look what we've got. We've got all the possibilities. We didn't have to compute them all, but if we find the smallest and the largest numbers for A, then the rest of the number is, determined by this equation right here. So our answer, the number of these numbers n that have the property that you can remove the leftmost digit and it'll end up being 1/9 of the original number, is 7. Alright, so the answer is that we have 7 of those types of numbers.